Hi guys. So this in this video I will just go through this lab session creating a date partition tables in BigQuery. So I have also uploaded two videos on these previous labs as well. Please check it out. I will just provide them in the description. So let's just hop into it. So let's start the lab. So this is regarding creating data partition tables in BigQuery. Okay, let's go through the overview. BigQuery is Google's fully managed, no-ops, low-cost analytics database. With BigQuery, you can query terabytes and terabytes of data without having any infrastructure to manage or needing a database administrator. BigQuery uses SQL and can take advantage of pay-as-you-go model. BigQuery allows you to focus on analyzing data to find meaningful insights. The dataset you will use is an e-commerce dataset that has millions of Google Analytics records for the Google Merchandise Store loaded into BigQuery. You have a copy of that dataset for this lab and will explore the available fields and rows for insights. In this lab, you will query partition datasets and create your own dataset partitions to improve query performance and reduce cost. Okay. So setup and requirements I have gone through several times, guys. So this is nothing but whenever you click on start lab button, it will just provide you credentials like username, password, GCP project ID. So that's the thing. So this is all this about, and we will just go to the Google Cloud Console. I will just open in incognito window, and I will just copy this password, and it will automatically fill in the username. I'll just paste the password, click on next. Yep. Click on agree and continue. Yep. So now, okay, what's yep. Open the BigQuery console. In the Google Cloud Console, select navigation menu, BigQuery. The welcome to BigQuery in the Cloud Console message. Okay. This is about opening a BigQuery service, guys. So here you can see we can able to see this BigQuery service in the navigation panel. Or else if you couldn't see this, you can just type it here, BigQuery. You will find this here as well. Yeah, cool. This is the BigQuery console. Let's see what are the tasks we need to do. Create a new dataset. First, you will create a dataset to store your tables. Click the three dots next to your Quick Labs project ID and select Create Dataset. Okay. Name your dataset e-commerce. I will just copy this. Leave the other options at their default values. Data location, default table expiration. Okay. Let's check this. Okay. I'm just keeping other values as default as they have mentioned. I will just click on create dataset. Yep. E-commerce dataset has been created. I'll just check my progress. Yep, good. Now, what is this? Creating tables with date partitions. A partition table is a table that is divided into segments called partitions that make it easier to manage and query your data. By dividing a large table into smaller partitions, you can improve query performance and control costs by reducing the number of bytes read by query. Now you will create a new table and bind a date or timestamp column as partition. Before we do that, let's explore the data in the non-partition table first. Okay. Query webpage analytics for a sample of visitors in 2017. In the query editor, add the below query. Before running, note the total amount of data it will process as indicated next to the query validator icon. This query will process 1.74 GB when run. Okay, so we'll just copy this query and we'll paste this in this editor, query editor. Okay, so this query looks good and I will just run this. Let's see. Okay, I got this data. what is this? Okay, let's go to the previous. Yeah, so click run. Yeah, we have done that. The query returns 5 results. Yes, as we can see, I have 5 records. So query web page analytics for a sample of visitors in 2018. Okay, let's modify the query to look at visitors for 2018 now. Click compose new query to create the query editor and then add this new query. Note the wait date parameter is changed to 2018 07 and 08. Yes, as we can see, the major difference between this query and this is 2000. We're just changing the year. Okay, let's just copy this query, and I will yeah, I'll open a new compose new query, and I'll run it. Let's see. So there is no data to display. Let's see. The query validator will tell you how much data this query will process. Click run. Oh, the query validator. Let us see. Okay, I think previously I have seen. Let me do it again. I think I missed that part. Yeah, this is a query validator. This saying this query will process 1.74 GB when run. Okay, cool. That's a query validator, guys. So click run. Yeah, we have done that. Notice that the query still process 1.74 GB even though it returns 0 results. Why? The query engine needs to scan all the records in dataset to see if they satisfy the date matching condition in the where clause. It must look at each record to compare date against the condition of this. So additionally, the limit 5 does not reduce total amount of data processed, which is a common misconception. Why did the previous query return 0 records but still scan through 1.74? Okay, let's see, guys. So before the query runs, the query engine does not know whether the 2018 data exists to satisfy the where clause condition, and it needs to scan through all records in a non-partitioned table. I guess this is the answer. Let's see other options as well. The query was written incorrectly. No, it was written perfectly fine. The query engine has the metadata for each partition stored, but still needs to scan all records even if the table is partitioned. Yep, I think this is this one. Yep. So common use cases for date partition tables. Scanning through the entire dataset every time to compare rows against a where condition is wasteful. This is especially true if you only really care about records for a specific period of time, like all transactions for the last year, all visitor interactions within the last 7 days, all products sold in the last month. Instead of scanning the entire dataset and filtering on date field like we did it in the earlier queries, we will now set up a date partition table. This will allow us to completely ignore scanning records in certain partitions if they are irrelevant to our query. Okay, so what they are saying is that if we can able to partition table based on a specific column like date partition, so it will just ignore all the other partitions which we don't require. I mean, based on certain partition date. Let's see. Yeah, create a new partition table based on date. Click compose new query and add the below query, then run. Okay, let's copy this query. Click on compose new query. Okay, I'm just pasting in this. Okay, click on run. Okay, it is still running. Yep, so it has created a new table partition by date day. Okay, so in this query, note the new option partition by field. Okay, partition by. The two options available to partition are date and timestamp. The parse date function, okay, is used on date field stored as string. This date field to get into proper date type for partitioning. Okay, so let's I will just go through this query again. Create or replace table. Okay, e-commerce dot partition by date. Okay, so e-commerce is a data set and partition by day is a table. Okay, partition by date formatted. Options. Okay. Select distinct parts data. Cool. So it is getting data from this specific public project with this data set, and this is the table which they are referring to. Okay, click on e-commerce dataset, then select the new partition by date by day table. Let's do that. Okay, clicked on this thing. Okay, then click on details tab. Okay, clicked on that. Con- Confirm that you see partition by day, partitioning on date formatted. Oh, let's just check. Partition by day, yes. Partition on field, date formatted, yes. As I think this field is represented in this query as well, right? So let's, yeah, date formatted. Yep, cool. Okay, this node, let's say, yeah, I think this is not necessary for this task. Okay, check my progress. Okay, please create a table named partition by date by running. I think we have done it. I'm not sure why it is still showing the error. Partition by day. Yeah, this is the same partition. Okay, I'm not sure why are we still getting this. We have done this one as well. We have created it, but I'm not sure what's the problem with this. Okay, let's jump into other task. I think we are I'm not sure again still. Okay, let's jump into other task. So view data processed with the partition table. So run below query and note the total bytes to be processed. Okay, let's check this thing. Okay, here I can able to see. I can Sorry, I'll close this. Here I can able to see, yeah, process 25. This query will process 25.05 KB when run. Okay, this time 25 KB or 0.025 MB is processed, which is a fraction of what you queried. Okay, because this is we are performing querying operations on the partition table, so that's the reason it is taking a lot of less amount of data. Okay, now run the below query and note the total bytes processed. Okay, let's just do that. This is again, yeah, 0 bytes. Okay, 0 bytes. Let's see why. You should see this query will process 0 when run. Why was there 0 bytes processed? The query engine knows which date partitions exist before the query is ran, and there is no 2018, okay, partitions. The query is running from saved view. This query is running from a query cache. No, I guess this. Yeah. Now, creating an auto expiring partition table. Auto expiring partition tables are used to compile with data privacy statutes. I'm not statutes. I don't know how to pronounce this, and can be used to avoid unnecessary storage, which you will be charged for in a production environment. If you want to create a rolling window of data, add an expiration date so the partition disappears after you are finished using it. Export the available NOAA weather data tables. In the left menu in Explorer, click on Add Data and select Explore Public Datasets. Okay. Search for GSOD NOAA and select the dataset. Let's do that, guys. Add data, explore public datasets. Now click on what was that? Okay, GSOD NOAA. copied it, and I click on that. Yes, view datasets. Okay, click on view data. Yeah, that we have done. Scroll through the tables in the dataset which are manually sorted and not partitioned. Okay. Wow, where was this? Sorry, I cannot able to see. NOA. Let me scroll through tables in which are manually sorted and not partitioned. I'm unable to see. Let me just add this. Add this again. Pin a project and a project. No, no, no. What's happening? View dataset. Okay. Dataset info. Okay, I can able to see, but editor. Okay, but I am unable to see the values. Scroll the tables in okay dataset which are manually sorted and not partitioned. Okay, but I am unable to see this. Okay, let's just jump into other task. Okay, continue. uh, your goal is to create a table that queries on weather data from 2018 onwards, filters to only include days that have had some precipitation, rain, snow, etc. Only stores each partition of data for 90 days from that partition's date. First, copy and paste this below query. Okay. Okay. Note that the table wildcard is used in the from clause to limit the amount of tables referred to in the table suffix. Regarding this wildcard, guys, I have there was one second lab, I guess, which they have explained about this wildcard. So you can go through that video and you can get a grasp of that concept. Note that although a limit of 10 was added, this still does not reduce the total amount of data scanned since there are no partitions yet. Click run, but I can see something is quite odd because they are saying 1.83 GB, but I can see only 536 MB. Let's see. Let's run this. Let's see. Click run. Confirm the date is properly formatted and the precipitation field is showing non-zero values. Non-zero values. Yep. Okay. From okay. Let's see. Okay. Now your turn. Create a partition table. Modify the previous query to create a table with the below specifications. Table name e-commerce dot days with okay. Use the date field as your partition by. For options, specify partition expiration dates 60. Add the table description weather stations with precipitation partition by day. Your query should look like this. Okay. So I will. Okay. So they just wanted to edit this query. Okay, and do that. Okay. Cool. I'll just as of now, I'll just try to copy this. Let's see if it works. It's still running. Yeah. Yep. Yep. Still running. E-commerce partition. Yep. Days with rain partitioned. Wow. You can see the icon. Icon is also different for this is Partition by day, days with rain. Okay, good. Yeah, this is done. So confirm. Okay, let's check the previous one. I'm not sure why still we didn't get that. Yeah, partition by day by running specified query. This is done. I'm not sure why this is not happening. Cool. Let's just see. Oh, this is done. Okay, now confirm date partition expiration is working. To confirm, you are only storing data from 60 days in the past up until today. Run the date underscore diff query to get the age of your partitions, which are set to expire after 60 days. Below is a query which tracks the average rainfall for the NOAA weather station in which has significant precipitation. Add this query and run it. Let's just add it. Okay, let's do. Okay, yep, we got this. So basically, it is selecting the value precipitation and doing some average functionality. Station name, date, current underscore date. Okay, date diff they are using here. Yeah, current date and this date which they are getting that as partition age. Okay, basically difference in age. Okay, cool. Confirm the oldest partition underscore age is at or below 60 days. Update the order by clause to show the oldest partitions first. The date you see there, add this query and run it. Okay, let's do it. Oldest partition. Okay, this we got it. Order by descending order. Okay, I mean, okay, your results will vary if you rerun the query in the future. Okay, let's just see, check our progress. This is done. This is not, I'm not sure why. I think there's a problem with this lab, guys, I guess. But I'll just go through what we have done in this lab. So initially we have started to create, I mean, started with this lab by creating a new data set, because in BigQuery, whenever we want to do something like creating a table or creating a view, you need to create a data set, and within data set you will be having tables and views. So what we have done here, we have created a new data set that we have done. Then we have created so this we so I've gone through this like creating tables with date partitions. So it explained about like how creating partitions will significantly reduce the amount of data read using queries and stuff. Then yeah, common use case that we have gone through. Then what about this? Yeah, the view data process with partition table. Yep, this is what done. So we have partition table based on a certain field. Then creating an auto expiring partition. Yes, so based on a certain date period, I mean using date diff, we have used this as well. Yeah, then created a partition table. So as we can see, partition by date, then partition expiration date. So this is what this entirely like creating an auto expiry 60 days. Okay, then date cast. Okay, these are the, so I have to dig deeper into this, guys. I will just create other videos where I will explain through queries as well. So this we have done, and we have confirmed the old partition age is at or below 60 days. Okay, so on a higher level we have created a data set, created tables with date partitions. Then we have viewed the data process with partition table. We have created an auto expiring partition table, and Yeah, just I mean, did some analysis on these partition tables, and have seen like how significantly the data amount of data read would be reduced because of this partition concept. Thanks, guys. Thanks for watching. I'm not sure why this still it is not working. Maybe some logic error, or I'm not sure. Yep. Thanks, guys. Thanks for watching. I will just end this lab. Okay. Yep.